Hello guys, I hope all of you are doing well. So today in this video I'm just gonna make you learn how to make a simple calculator using an ATMEGA328P microcontroller, and we will use the IC MM74C992 in this so as to encode the 16-bit numbers from the keypad and then convert them into the 4-bit, and after the certain processing we will see that the addition and the subtraction will be performed at the time. So we will store the first inserted value in one register and the second insert value in the second register, and after that, pressing the certain button, the operation will be performed. So first let's see and simulate it in the Proteus. So here is the ATMEGA328P that is usually used in Arduino UNO. So this is the IC MM74C992. So first we will see that we have to just insert any one of the number. For example, you can see that if first LED is turned on, means that I have to insert the one value that I should insert it in the register, or here you will see that, and after the blinking of second LED I will insert the second integer or a value from the keyboard, and the third LED will blink in the situation, so I have to put the plus or minus sign, and after that you will see that once the loop is completed, the operation will be displayed here. So first you can see that I have just inserted the 2 value here, so this LED is going from here to here, and then I have also inserted this and then click the plus. Here we see that the 4 is appearing here. After that, if I just subtract just like 2 minus 2, so here we'll see that I have just clicked 2. Now the loop has been started, then again press 2 and then subtract, so you will see that 2 minus 2 is equals to 0. After that you will see that I will insert 7, so it has now read the value again. I have inserted 7 and again added it, so you will see that E is appearing here, means that 7 plus 7 is equals to 14. So 14 in hexadecimal is generally E. So if we go towards its source code, and you will see that after just stopping the simulation, and the source code is just like this. Here is the rjump start command, means that after the execution of every loop it will jump to the start. So here you will see that the start function is executing from here, and I have just loaded the R16th register with 0 value and R17th with 1 value, and after that I have affiliated these values with registers DDRB and DDRD. So here the DDRB is working as an input port and the DDRD is working as the output port. So now I have sent SBI send bit immediately to the port C and pin C 0, and then you will see that after that I have called the input 1 function, means that I have inserted the input 1. So now coming towards the input 1 function, you will see that the input 1 function tag is called, and the input will be inserted into the R18th register for pin B, and then a certain delay is called. And for example, if I have inserted any value from the keyboard in a R18th register and in pin B, so it will what it will do means that if I have just clicked here, and the 4-bit output are generally appearing here, so I will encode every input and every output here. For example, when I was pressing 0, the output was 0111, so I have just make the 4 bits empty, and the 4 bits I have loaded with 0111. So here you will see that subtraction of R19th register with the register that I have taken as an input will result in the 0, but if the subtraction of these both of the registers will 0, the value will jump towards the LDI, means that both of these values are equal, means that I have inserted the exact value that I was expecting. So the LDI will be loaded with this, and then the loop will return. So if you can see that these values are not equal, means that I have pressed any of one button just like 1, and here you will see that the value here is 0000111 in the R19th register. So subtraction um, will not result in the one value, so it will jump towards this loop. So the similar comparison will be done here, and it will compare all the values. You can also use the CP command here to compare the values in both of the registers that you have saved as an input or the values that you have inserted before as well. So here you will see that I have already called the input1 function and then cleared the bit of the port C0 and S, send the bit immediately to the pin C1. Means that it is just showing us the LEDs that will blink and let us know that when should I insert the data in the ports. So here we see that I have called the input3 function. The input3 function is similar to the above that I have explained earlier, but here the tags are a little bit changed from 0 to 01, and all the registers are also changed, but the values and algorithms are similar to that. So this function will be called, and after that you will see that cleared the bit of the port in the pin C1 means that the LED will turn off and the third LED will turn on, which will result us in the insertion of any of the plus or minus sign. So you will see that this is the entire function that we have to just you can see that add or subtract the two numbers that we have inserted before as an input 1 and input 3, and this is called delay function. And here we see that this is the delay function that I have called r 7 times and then 200 times and 200 times, means that it is 4000 into 7. So this loop will be called this times into this time into this time. So and after that multiplying this entire multiplication value with the microsecond will result in 1 second or approximately less than 1 second delay. So this is the code here, and now we will go on towards the second question code, second question statement, in which we have to just do the following things. Means it is saying us that we have to just perform the operation A, operation B, and display it in the port B. Sorry, it will take the data input from the port B and it will display the data into the port D, but the port C will be act as the controller port that will perform the different types of the functions. For example, just to show you the simulations as well, here you can see that I have used the Arduino Mega in order to show you the complete number of the ports, because in Arduino UNO one port of C and B is missing. So here are the complete number of the 8 total ports. So here the code is here, and you will see that the commands of the different types will be executed in such a way. For example, if I insert, this port is working as a controller port, but this is the port that is used as the output, and this is the port that I am inserting the values here, and the operations will be performed in this value with the help of this port, and the display port will be appeared here. So the first thing here should be kept in mind that after the simulation you will surely see that I have inserted there the value like that. So if you can see that 3 is appearing here, 63 means, so we will go towards the code is not appearing here. We have to just stop the simulation as well. So the 63 value is here, so it will multiply the values, and it will add the values in 64. In 65 it will use the OR operation on the values, and then it will use the NOT operation on the values, like that. So these are the different operations that we will perform while adding the different types of the values. You can see that these are the case statements or if else statements, but in assembly language we use the breq statements to jump that statement to the particular loop in which we are executing them. These are the tags that we have already called in the breq commands as well. So if you can see that I am using AND command and plus command, so I will move on towards the plus in order to show you that I will insert 61. So the answer should be appeared the double of the value that I have inserted in the. So here you will see that I will insert just 61. So you will see that 3 is adding in itself, and this 3 is also adding in itself, means that it is performing the bitwise operation, and the 6 is appearing here. But if you can see that just adding 7 and 3, so you can see that 7 plus 7 is equals to the 14, that is E in hexadecimal, and 3 plus 3 is equals to 6. After that you will see that I'm just again adding 7 and 7. You will see that 14 and 14. So this is E and E appearing here. But if I will insert well, you can say that 5 and 5, and you will see that double A is appearing here, means that in hexadecimal 10 is equals to A. So this is completely verifying our results as well. But if you can see that I am just performing the AND operation on this, here you will see that this is the AND operation. So I have to insert the 64 value in order to make the AND operation working. So I have to just insert the 64 value, means that it is 100. So here you can see that it is performing the AND operation, means that in general in AND operation 1 plus 1 is equals to 1. So here the 5 plus 5 will be equals to 5, and this is also performing the AND operation in itself and producing the 5 here. So this AND operation is also working very well. So this was the video for today. I hope that you will really enjoy this video. But if you really like this video, please like, share and comment. Bye bye for today.